In our first example here, we want to graph these two functions, f of x and g of x. And we want to graph them on the same set of axes, which is the rectangular coordinate system. So that we can compare the graphs looking for shifts. Okay. So let me graph the first function, f of x equals 3x. So I can start with the y-intercept, which there is none, so that means it's 0. So we're going to plot a point right at the origin. And then I can use the slope to go from there. And so that's going to be always going right. So up 3 as we go right 1 for each of those points. Or we could go the other way. We could go left 1 as we go down 3. And you can graph your line there by connecting those points and put arrows at the end. The arrows are important because the line goes on forever. Then we want to graph the other line. G of x is 3x minus 4, so we can start with the y-intercept, a negative 4 here on the y-axis. And then the slope is the same, so it goes up 3 as we go right 1. Or we could go left as long as we go the opposite, so down 3. And connect those together to form your line. So there are some similarities and there are some differences, right? So what's the same? They have the same slope. And they're both lines, right? So what we're actually looking for, though, are shifts. So how is it different? How is g of x different from f of x? Well, it looks like every point is down 1, 2, 3, 4, sorry. 1, 2, 3, 4. 1, 2, 3, 4, right? So every point is down 4 units. So that's the important thing that we're looking for. That's the shift here. Can you see that from the functions? If you were to look at those, can you see a downward movement of 4? That's something we'll focus more on in a future section coming up soon. We want to do the same thing for number 2. Graph f of x equals negative 12x and graph g of x equals negative 12x plus 3, and we're going to again be looking for the differences because we can probably already see what the similarity is, and that is again the slope. So we've got our y-intercept here and negative 12. Are you serious? I'm going to have to change the scale of the axis. So instead of 1s, these are going to be 2. So negative 2, negative 4, negative 6, negative 8. Then negative 10 and negative 12. So from that y-intercept, we're going to go down 12 and right 1. And so I can change the scale of the x-axis. That can be just regular 1, 2, 3, 4, 5, 6. But the y has to stay 2, 4, 6, 8, 10, 12. Just to stay consistent here. So then we're going to go down 12 units, right 1. And then I'm going to go the other way, up 12 units, left 1. And connect those together for my line. So now we want to draw g of x on the same axis. So negative 12x plus 3. If we start at 3 for the y-intercept, that's there because it's between 2 and 4. And then we want to go down 12. So 2, 4, 6, 8, 10, 12, and right 1. Or we can go up 12 and left 1. And then we will connect those together. And they're very close together, but we want to check and see if we see any shifts here. So again, they have the same slope, so they're going in the same direction forever and ever. But how are they different? Let's look at the points. So from, say, this point right here on f of x, then that next point on g of x is up 1, 2, 3. If you look at this point here, 1, 2, 3. So each point of g of x, and there's a lot of points, not just the ones I pointed out, but every point on the line is 3 points, or 3 units, sorry, higher, or up vertically. And so that's something, again, we're going to want to think about for a very coming up section here on shifting, if you can see that the 3 units is there in the graph.